So the objective of today's session is actually going to link back to what Sridhar presented yesterday. So we're going to talk about a couple of things. There were quite a few interesting points which came up in our discussions yesterday. One of the first points was, how does the business and the IT divisions actually talk to each other to make it a very, very relevant discussion for the organization's good? So that's one thing we will talk about. And the second is, of course, the fact that recession has actually woken us up. Not everybody really had a financial crunch. It was not really about the fact that people didn't have money, but it was about the fact that you didn't know what the future looked like, so everybody wanted to conserve money, cut down on the costs, so that probably you can last a longer recession. It was the objective, and which is why we had some of those problems in the last 2 years. There were lots of customers I personally know who had projects, who had issues which needed to be solved by buying equipment, by buying software. But because of the way the market was like, everybody said, no, let's not spend the money, and let's wait and watch. So what's really happening, and which is the way we need to go, that's what we will talk about, and I'll especially focus on what is going to be the data center of the future like, which is where you need to take your core technologies. So this is the core. The core is that it is only the efficient who will survive, it is only the efficient who will thrive. That's what everybody's been talking about in the last 2 years. And then we talked about briefly our efficiency proposal. So let me give you a little bit of a deep dive into what the efficiency proposal is all about. India has a financial year that starts in April and ends in March. So come 1st of April, we mentioned that 80%, between 70 and 90%, so let's assume 80% of your money is spent. But how many of you actually know which is that 80% which is spent? So I'll take a minute and sort of quantify that. And before I do that, I'll do a quick dipstick poll. How many people here actually look at the electricity bills of your data centers? How many people actually look at the air conditioning bills of your data centers? Do you actually see those? Do you have access to that? Do you influence it, right? Absolutely fantastic. So the money, when we say that 80% of your budget is actually spent on the 1st of April when the financial year starts, I'm talking about the air conditioning bills, I'm talking about the electricity bills to run your data centers, I'm talking about your annual maintenance contracts, I'm talking about your software license fees, and obviously I'm talking about the hardware maintenance contracts and the salaries you've got to pay. If you look at that part of the pie, that is your fixed 80% of the expenses, and these expenses are done for you when you start in April. What you have left is maybe 10 to 20% of the rest of the budget, which is what you need for innovation. And as I talk about the data center of the future, I'll gradually build it out for you so that you can visualize it and understand how you can start building. I don't expect you to build your data center of the future tomorrow, but as your first and the second and the third step, as you start building out the data center of the future, this 80% will start shrinking. And how will it shrink? If the number of physical servers goes down, you need less air conditioning. You need less electricity to power the air conditioner. You need less electricity to power the data center. That is where the savings will flow in. So you invest more, you save more, and finally you have a scenario in which your fixed expenses, the money that is spent for you when the month of April comes, will actually go down, which means you will have more money to innovate for your organizations. And then I'll briefly talk about what sort of innovations you can actually give back as an IT department to your sales functions, to your business functions, to add real value to your businesses. So I actually sort of wanted to take an example to illustrate my point, and let's look at a few scenarios. So there are a couple of gentlemen I met who are from the education industry. What happens is we start admitting our students typically in India in the month of June or July. So there are 15 days of admissions, and 15 days is when all of those huge number of students come in who need to be admitted. Your IT systems need to be optimized to ensure that you can admit all those students at that point in time. You're not doing any fancy processing. Your only objective is to get your students in. Okay? Let's take another example. Let's say you're a manufacturing company. All your customers want their deliveries and their invoices done maybe by mid of March, so that they can make your payments by end of March, and they can close their financial year, which means you have a crazy pressure. You've got to manufacture your equipment, you've got to get your financial system running so that you can bill it out to your customers, they can get it. So where is the load? There is no data warehousing load. All the load is on your financial systems. All the load is on your manufacturing capabilities. Okay, and then let's take another example. Let's say an insurance company. Okay, when do you get a workload? Normal scenario, you sell your policies, customers buy those policies, and normal scenario, let's say I have a disaster, I call up an insurance company and I get help. That's how it works. Okay, but what happens if there's a disaster? So every industry, there are peaks of loads, and then there are times of troughs, when the workload is much less, and just about any IT system can run it. The biggest issue I believe CIOs face today is everybody knows where the constant business is, everybody knows where the constant business is going, but nobody knows how to plan for those excessive extremes. And if your business can get a support from IT departments to adapt to those peaks, okay, and if it is not going to cost you any extra money, I don't think anybody's business would be happier than that. Because normally what happens is you want to plan for peaks, that's why you buy 4 times what you really need. But you never actually get to utilize it. Okay, and whenever the peak comes, you never have ample capacity. So I'm going to try and take the example of the insurance company just for convenience sake, not that you are in an insurance business, just to give an example of what happens. So let's look at this. It's a normal insurance company, they're running a normal business. They have customers who call in, so they have sales agents on the phones. They have evaluators, so let's say something happened, there was a bomb blast or something else went wrong and my house broke down. So I call up the insurance guy, he comes in, he does a survey, and based on that, maybe in the next 3, 4, 5 days, I get a claim. Or let's say I have a car and something goes wrong, meet with an accident, and what's the process? The process usually is within 24 hours I got to inform the insurance company. So they have an average run rate on an average day, let's say they see two accidents, so they will have enough people to cover it. Okay, that's their normal business. That's how they have designed their business. And they have built their data center to support that business. So they will have bought storage for that, they will have bought servers to run that part of the business, they will have software, and obviously, technology means they will have all of these people using some form of mobile devices. I've seen insurance agents nowadays, when they come to renew my car insurance every year, the guy actually uses the cell phone, takes a picture of my car to say that, yeah, I actually physically saw the car and it wasn't dented. Okay, or if I want to change the insurance company to a new one, and even if it's under a no-claim bonus, he will still use a cell phone. It's convenience. You don't have to carry fancy cameras anymore. You don't have to carry technology with you. You don't have to take it to a service center to get it checked. You get it done just very easy. Everybody can plan for a scenario like that. You can build a static. In fact, everybody probably has a static data center designed to address that. But let's say this is what happens. Okay, there's a hailstorm in Delhi. Doesn't happen ever, right? But that's an example of an extreme scenario. And suddenly one day there are 300 cars damaged and there are 25 other organizations having some other intangible issues. How does this insurance company handle it? This challenge is no different from a manufacturing organization where you are shipping, let's say, 100 units every day and now you receive an order for 10,000 units. Okay, and then you have 20 days to deliver it. That's your peak, that's your surge. You cannot be buying equipment, software, people, because you anticipate a surge. You've got to plan for it, but you've got to have a different game plan to handle it. And that's the point that I'm trying to get to. So again, back to the insurance company example. What do? Suddenly you have 300 cars to look at, and you don't have people who can handle more than 5 cars a day because your run rate was maybe 2 or 3. Okay, or maybe 10 cars a day, that's it. Okay, and then your policy tells your customers that their cars have to be served within 24 hours. Guess what? It's a no-win situation for the customer, it's a no-win situation for the person who's providing the services to him. Don't want to use the word vendor because some people don't like it, but the reality is yes, it is a vendor-customer relationship. And because the vendor has made rules, it's the customer who can come up with his expectations. How do you handle a scenario like that? So this is a typical dilemma that every single organization faces at some point in time, and that is why you create what we would like to call as over-provisioned data center. An over-provisioned data center is which can do a lot more than what your normal expectation is. The only issue is how much more you want to plan for. Do you want to plan for 3x? Do you want to plan for 5x? Or should you plan for 20x? That's a guess. That's an intelligent guess. Nobody really knows what is going to be the load you will be running, you will be managing. So again, back to the insurance company examples. Now you probably contacted some people from outside to do that work, to go check out all those cars damaged. They again use their cell phones. Now instead of 5 people, there are 50 people trying to upload pictures of damages back into the insurance company servers. Guess what? The servers were now never designed to take that load. So they start crumbling. the entire infrastructure slows down. Can you narrate with that issue? May not be on such a huge scale, but things like that happen in every single business. Nobody, absolutely nobody is going to plan for a 10 times load because you think you might ever hit it. So what's the solution? We believe that a data center of the future needs to be dynamic enough to be able to handle scenarios like this. It needs to have the capabilities to deal with a situation like this without actually buying 10 times more equipment. Now let's look at the word shackles. You literally change stuff. So how is it that you build data center? And I was doing a quick dipstick survey of how many people understand, can go a little bit deeper into technical parts. So what I was really trying to understand was, when you actually buy storage, it's physically hardwired to a switch. Could be a fiber channel switch, could be an iSCSI switch, whatever. Okay, that is physically hardwired to a server. So we built a data center. We've got 100 servers. We've got storage to support those servers. We've got a network. Let's say out of those 100 servers, 10 are the CRM servers that handle customers. 10 are the servers that handle your insurance agents who actually make the sales. So you have 10 servers for sales, 10 servers for customers. Let's say there are 10 more servers who are actually used by the guys who handle the damage that happens and upload information into those servers. Okay, and then you have another 40-50 servers at the back end which probably do your salary processing, which probably do your finance and accounting. In a disaster scenario like that, the key is not to pay your customer the money upfront in time. The key is that you have a 24-hour window to capture all the data. So if you wanted to increase the number of servers that handle customer requests from 10 to 40, you have 100 servers, right? You can always reduce the number of servers that handle your salary from 10 to 2. You don't do salary on the 10th of the month. Okay? You could probably reduce the financial workload. You could probably reduce 10 other things. And just ensure you can give extra assets to handle this huge surge in demand from customers because you've got a particular problem to handle. But the way data centers are built, they are hardwired, they are shackled. This is what they look like. You literally change stuff. You tie it all together. Everything is hardwired. So our vision for the data center of the future is these shackles need to go away. The chains need to go away. The environment needs to become dynamic. Okay? And a lot of vendors like to use the word virtualized. But this is what happens. Virtualization is also a fairly open word. You can virtualize servers, which means your computing power. You can virtualize your storage, which is your actual capacity where you put information. You can virtualize it. You can also virtualize your I/O, which is how you do the interaction between these devices. The issue today is that most people will give you a solution centered on one of these. Okay, someone will tell you what using server virtualization to fix all your problems. I don't think that's the way to go. Someone will say use storage virtualization because that's where your data sits. That's the center of your universe. What we believe is that unless you plan for a strategy to get all of these three critical components into a single picture and then build out a solution, you will not get what we believe is a comprehensive solution for the data center of the future. So an efficient enterprise actually needs a very, very well-designed data center strategy, which will take you from here to something in 3, 5, 7 years from now, which will be the relevant technology that you need to use when you reach that point, because your competitors will otherwise overtake you. So what's this static versus dynamic? Static is when everything is fixed, okay? It is a working environment, but everything is hardwired. So 10 exchange servers means you have 10 servers running exchange, full stop. You can't turn it into 20, you can't reduce it to 5. Okay, you have SQL servers, okay, in the application. Let's say you have a sales CRM set of servers. Okay, yesterday you were talking about a gentleman facing a problem with his ERP environment. Yes, you've got hardwired servers. You can have virtual servers, you can have physical servers. There are certain applications which still do run good on physical servers, and especially the software licensing makes it very hard to take them to virtual. So it's not fair to say that you virtualize everything. Maybe you will virtualize 60, 70 from 20%. But you will have a scenario where you will have physical machines, you will have virtual machines. But the objective of this discussion is, can we make it all dynamic? So how does it really work? This is a nice utopian picture I've painted. The good scenario is you have 10 exchange servers, you have 10 SQL servers, and because you've got more exchange load coming in, out of the blue, somehow your SQL servers need to turn into exchange because you have got more mails coming in. Okay? Or maybe in the scenario of the customer where we had that disaster, you somehow need more communication for all the agents on the field. But can you just sit and do it? Is there a way you can do it today? I don't think anybody has an answer to that problem. And the answer to that problem is going to be the data center of the future. So let me give you a little bit of a logic of how you could possibly build it. Let's say there is no more a concept of that server being an Exchange server and this server being an SQL server. Let's say in the environment I build, that's a server A and this is a server B, and I don't care what runs on it. And what I do is, I actually maintain a database of what you would like to call as personas. So I have a persona for a mail server. I have a persona for a database server, okay? And today morning I get up and I know that I need 20 database servers, so I push 10 personas to 20 of those servers, and guess what? 20 servers become database servers. These could be physical or virtual, there are no restrictions. This could be Linux or Windows, no restrictions. Okay? My need is, today morning, I need 20 SQL, out of those, that huge set of servers I have, I need 20 servers. As SQL servers, I should get 20 servers. These could be dynamic, which means on the fly you could convert, or these could have a little bit of a transition time, maybe you need half an hour to reconfigure. But I should be able to do that, because that's what my need is, right? Because the technology prevents me from doing that is not the issue. The issue is, what's our need? And then I will take you to the solution to that. So we need to have this concept of personas. Every single persona will have a very clear definition. And then we use these personas to build something out. And this is where it takes us. We have a purely dynamic environment. What's a dynamic environment? A dynamic environment is where, you can see this picture, we have a certain set of servers, which is, let's say, a .NET environment. Maybe this is your Dell servers, okay? And tonight, I know something wrong has happened, or I know that I have this huge production thing coming out, and I've got to do a big amount of invoicing tomorrow, which means I probably need to run a lot of databases, or maybe my database runs on Linux. I should be able to reconfigure it. 12 o'clock in the night, I give this instruction, and nothing is really working. Next morning I come up, the entire data center is reconfigured. It isn't as simple a challenge as it seems to be. You know why? Because we have VPNs, virtual private networks. So this server is physically wired to this, it's all hardwired. You can't just change it because you feel like changing it. Okay, so the entire infrastructure, your storage is wired, it's wired fixed to a particular name on the switch, which in turn is wired to a physical server. So you decide to use a different image on the storage, which is no more Windows, which is Linux and a database. And you want to use that on a server, is it going to work? No. So you need some very serious technology to fix this issue, to break those chains so that your entire environment becomes dynamic. It's no more static. Now, if I had a solution like that for you, if this is what I could do to your data centers, the options are just about infinite. So let me take an example. Let's look at the first one. Let's say in static environment, you have a form of servers which you use for testing. Then you have another form of servers which is production. And there's another form of server which is standby. Things go wrong, you use it. Now, if I could give you this dynamic environment, you can actually get rid of one complete form of server. You know why? Because you don't need to test servers anymore. You can probably use those idle servers as your test servers. And when things go wrong, what happens? You just turn off your test servers, you reconfigure them by clicking on the different persona, they come up and they become your DR servers. You still on the same page with me? So here's the thing. I have a group of machines which is testing. I have a group of machines which is production, and I have a group of idle machines which are there because if something goes wrong here, I can fail it over to that. That entire bunch is idle. Okay? Now in that dynamic environment, I don't need to do that. I can get rid of that off because when things go wrong on the production, I use the new persona. I push this persona. So here is this server. There are 5 Exchange servers which have the persona called Exchange 1, 2, 3, 4, 5. I reboot those machines with that persona. Now you are Exchange 1, 2, 3, 4, 5 because this site is down. You can seriously consolidate. This is no more about virtual consolidation. It is no more about replacing 20 physical servers with one virtual server. This is about using a different set of hardware with a different set of hypervisors to do this job. In a dream scenario, it will even be hypervisor agnostic. You could have physical servers popping up there, You could have VMware servers turning up into a Microsoft Hyper-V server. You could have Zen-centric servers. That is what the real dream scenario should be. Okay? That is your data center of the future. And trust me, gentlemen, it's not that hard to do. The limitation is in our own heads. We think it's hardwired, it can't be changed. And I repeat the word, we think. That's not the fact. If you remove those shackles, here's another case what you can do. So I just did this reconfiguration. Here's a second example. I can do N+1 failover. I don't have to cluster everything. I have 20 critical applications. I need to buy 40 servers, pairs clustered with each other, right? I don't have to do that. I will buy 20 servers and maintain 5 as standby. Okay? And if things go wrong, I can do this. One server crashes, guess what? I just move that to something else. Because it's a persona. I turn off the persona on this faulty server and turn it on another machine. That's a dynamic data center. That's where you need to go. That should be the utopian environment you will target. But that, I believe, is a realistic technology that can be implemented over a period of time. It doesn't take that long. Another scenario, disaster recovery. Simple. I just turn on the personas on the primary site, turn them on the secondary site. Works? Again, another example. I can even do it physical to virtual, virtual to physical. Again, let's go back to the example of an Exchange server. Because I had huge workload, I was using 4 physical servers as Exchange servers. When things go wrong, do I really need to support all the 10,000 users? Maybe not. Or do all of those 10,000 users deserve a 5-second response time? Maybe not. You're okay that you get a mail in 15 seconds, it works for you. So you can turn those 5 physical servers into one virtual server. This is what? You turn off 5 physical server personas. I had a physical server A, B, C, D, E, all Exchange. And I had a virtual server running VMware, Hyper-V, whatever. And yes, I turn all of these off, and I bring them all in a virtual environment now. Do you believe that would be a beautiful little world for you? Are you convinced that if someone could implement that for you, that would probably be the direction for the future? We believe so. We're working actually in that direction. So what I would like to actually point out is it's all about making some really hard decisions. It's all about making choices. And I think the first choice is you've got to choose the right partner. Okay, and how should you choose the right partner? Pretty simple. You need a partner who should be open, capable, and affordable. And I repeat, he should be open and capable and affordable. Because the problem in our industry today is you can get open technology, it's often not capable. You can get capable technology, okay, but it's usually not affordable. And if you buy affordable stuff, it's usually not capable. So there are people who can do one of them. But we believe your right partner should give you all 3. They should give you an open technology. Open is not about a really deep discussion on whether Microsoft Windows XP is proprietary or not. Open is about choices. Can you choose? If you don't like this, can you choose something else? That's open. Capable is about the fact, will it give you that big picture performance tomorrow, even though you're starting here, without losing that open. And affordable is not the cheapest product in the market, but affordable is open, capable product at what price? And the guy who gives you that at the lowest price is the one who's going to give you an affordable product. This is important, the right partner, okay? And when I say open, this is what I meant. I'm actually getting down to the nitty-gritties of it. Let's look at the networking piece. Let's say I'm Juniper. I shouldn't do only Juniper. I want Cisco, let's say I have a very large fiber channel infrastructure which usually is Brocade, so I want Brocade. I want everything. A good partner should take care of all of those things for you. A good partner should not force you on one hypervisor. Or a good partner should not force you only on virtual servers. A good partner should be able to support both your physical and your virtual environment, because again, there are certain things which still do run better on physical. There are very few now. They're shrinking over a period of time, but there are. So you can't just get rid of that stuff. You need it. Okay? And it's about supporting multiple vendors. So if I come and tell you, yeah, you like Dell, I like you, but guess what? Let's throw everything away and then you go on Dell. No, that's a bad partner for you. Or it could be HP which says that, hey, just HP, I'll throw IBM and Dell out. It doesn't work like that. That's not how your business is built. You have some equipment you bought, right? Which is let's say 1.5 years old. You want it to live for another 3 years, get your money, work on it, and then do it. So it's not about a rip and replace environment. Everything has to be supported by a good partner, and there has to be a gradual transition path. That's what will give you the real value. So data center of the future, in our opinion, is a reality. Okay? It's not a one-time experience. It's a path. You will take some time to do it, but it can be done today. Okay? But the important part about that is remove those hard lines you have in your minds that it's a hardware data center. Remove those shackles. Pick up the right partner which has the right long-term vision, not the right deal price, and then work through that. And you will get your data center of the future. Thank you, gents.